In this video, I'm going to show how can you code the optical flow algorithm by Horn and Schunck. So this particular algorithm in Matlab. So let's see how can we do that. So let me explain the code line by line so that you understand. So here I'm going to read the input. So there are two images that I'm going to read now. So let us see those images. So I'm running Matlab in debug mode. I set a breakpoint over here so that I could just run till this particular line. So now you can see that these two variables are created over here. So this contains this first image and A2 contains the second image. Let me show you how does the image look like. So we use IMShow for that. So if I do IMShow A1, yes, so this is one synthetic kind of an image that we are going to use, and this is the other image. So visually, if you see, both of them look the same, but actually there's a small difference. So there's a small difference that this particular box is shifted by 1 pixel to the right, and this box. So we'll see that in the algorithm. So that is our image. Now you can see that it is color. So there are three different. So this is a 3D kind of a thing. So first let us convert it to to grayscale. So for that we use these two commands. So now you can see that it has become 2D. Now I take size in B1. I have converting uint it to double. So that is very important, converting to double. Next, as we have seen in the algorithm, where's the algorithm? Right. So we need to compute fx, fy, and ft using the masks, right? So these are the masks that we have. Yeah, yeah. So these are the masks that we have. So this is the fx mask, the fy mask, and the ft mask. So that is the same thing that I've done here. So this is for the x mask. I've named it as rx, and this is the y mask. I've named it as ry. So that is what I've done. So now initially I have created zero matrices for fx, fy, and ft. We are going to update them over here. So currently we are going to create fx, fy, and ft. So how can we do that? So there is an for loop for that. So for I is equal to 1 to b1 of 1. So you can see b1 contains the size. So this is the size of the image. So b1 of 1 is the number of rows, number of columns. So you have to go till the number of rows minus 1. Why minus 1? Because I say this is the mask, this is the Rx mask, and this is your image. So what will happen is first the mask will be applied over here. That is this particular 33 will get multiplied to minus 1, 20 to 1, 26 to minus 1, and 13 multiplied to 1. And then this thing will be added. Everything is added and stored. So that is how convolution happens. Now what happens is, as in when you are moving, there'll be a point where you will go out of the image. So here you can see when you are over here, this is minus 1 into 30. So not this. So when you are over here, so when 31 into minus 1, 35 into minus 1, like this. So you don't have anything over here to get multiplied it to 1 and this one. So because of that, what I'm doing is running the loop. Uh, I'm running the loop my till number of rows minus 1. So in that case, I and j will only be restricted till here. So this will be the last pixel that will get uh, convolved, so that I can put this over here and you can have the you won't go out of the window basically. So that is what I've done over here. So you can see a -1 over here. Next, this particular thing is same as I have explained in my video, that you have to take the average of the first image convolved with Rx. So that is right. So take the first image, that is say frame T, convolve it with Rx plus the second image, convolve it with again Rx. So in this case, fx masks, both of them are the same, and then you just take the average. So that is what I've done over here. My zero point 0.5 into, so here this particular thing extracts the image vector. So if suppose this 33 is the ith and the jth pixel, so say initially I and j will be 1, so it will point this particular, let me use a pencil, yeah, so it will point this pixel over here. Now what we can do is we want to multiply 33 with -1, 20 with 1, 26 with -1, and 13 with 1, right? So what we can do is we need to extract this particular vector outside. So I have ij, so this pixel becomes my ij, this 33 becomes my ij. So this pixel over here becomes I comma j plus 1. This pixel becomes I plus 1 comma j, and this pixel becomes I plus 1 comma j plus 1. So like this I can extract the whole vector outside of this image and then multiply both of them. So that is what I have done over here. So I have taken I to I plus 1 and j to j plus 1. So this will extract the whole vector that I had shown, and dot multiply. Dot multiply is element by element wise multiplication as we want. So this is element 33 into -1, 20 into 1, 26 into -1, and 13 into -1. If you don't put the dot over here, then it will take it as matrix multiplication, as we multiply in matrices. Number of these row will get multiplied to column, like that. So that is not what we want, hence we have a dot over there. And the same thing for the second image, and you add both of them and take the average. So this is for fy, the same thing you can do for this is for fx, the same thing you can do for fy, just that the mask will change. Now there is the ry mask. And for ft, if you see, as such you don't have a mask, it is just that all these are -1s and all these are 1s. So basically take the particular window out and just multiply, just subtract it. That is what we want. So you want to subtract the first image out of the second image. That is your main purpose. So that is what we can do over here. The second image is positive and the first image is negative. So that is what we are doing here, and this sum basically gives you the sum of all these values. So it will take the sum of all these values and it will give you the output. So like this we can create the fx, fy, and ft images. So let me just come here. Yeah, so now you can see we have created the fx, fy, and ft nicely over here. Now we have to create the u and v matrices. So to create the u and v matrices, we have seen in the video that first thing is to algorithm. Right. So the first thing is to initialize u and v as 0. So that is what we are going to do over here. So here I have initialized u and v as 0. I have also taken a new variable u1 and v1. You'll understand why I have taken this in a minute. And I have the Laplacian mask over here. So this is the same mask that I have used in the video. So that is the mask. Then you have to set the lambda value that defines the weight. How much weight do you want to give to which particular constraint? And there is this loop. So I am running this loop for 40 iterations. So this loop is the whole algorithm. How much times will I repeat these steps? That is this loop. So this is going to repeat for 40 times in my case. So you can have any constraint over here. So that is 40 over here, and what I'm doing is the same thing. You have to convolve u with the mask, so that will give you u average, right? This is the Laplacian mask that I have, and you have the formula for p. So just put in the formula of p over here. You can put in the formula of d over here, and then calculate u. So let me just keep the algorithm side by side so that it becomes easy for you to understand, right? So you have to make this formula basically. So that is what I've done over here: u average minus fx into p by d, where this is p and d. So that is what you can do, and these values I'm putting it into a matrix that is u1, which I've initialized over here, and v is into v1, which is again initialized over here. And after the whole thing is completed, I am changing. So that this is the update. So now the u1 is becoming the u, and v1 is becoming the v. So what will happen is u and v got updated. Next time this will be the u and v value, and again u1 v1 will get updated. Again that value will go to uv, and the process will continue. So like this we can get the u and v vectors, and the final thing is just plotting. So let us see what is the result. So this will take a little time because I have to run, the Matlab has to run it for 40 40 iterations. So here you can see the plot. So this is sort of velocity plot. So here you can see that these pixels have moved in this direction, and these are the pixels that were in the box. The see so right. So these pixels that were outside, that were not moved. Only this white box was moved by 1 pixel. So that is quite evident in the plot. So this is the first result that I wanted to show in this particular program. Next, what we will do is let us go a little bit real, and let us see what happens when you run this algorithm in the Hamburg taxi sequence. So I am going to do a little bit changes for that. Right, so let us see what happens. I hope I have done things rightly. Okay, I feel I don't need this. I will need this. Sorry. So I use Control R to comment any line that is selected, and Control T to uncomment it. And I've used Qver. This particular thing will give me this kind of a plot that I have plotted over here. And this UV is the matrices that I have got from here. And B just means that the color of the arrows should be blue color. That's it. So you can see further details in this particular help menu. So this is a very nice kind of function where you can get these beautiful plots, right? So I feel now everything is all right, or else it'll give you an error. We'll see that, right? So let us start. So now if you see, I have a GIF file that is of the Hamburg taxi sequence. So this GIF file I'm going to read. Right, so this is a 4D kind of a thing, this GIF file, and if you see the size of this particular thing, so you can see that the size is 417 cross 555 cross 1 cross 41. So this one is because if it would have been a color image, this would have been 3. So since this is a video, so because of that, this is what is happening. So you can use this squeeze command. So this squeeze command will remove any dimension that is of only one character. So yes, so you can see when I squeezed V and put it into capital A, so now here you can see that it is a 3D matrix and it has these values over here. So that is what we have. Next, what we are going to do is we are going to resize it because this image is a little big, so it takes a lot of time. So I am going to resize it by half. So resizing it by half, what happens is I can do it a little fast so that I can show it to you. So initially what I'm going to do is I'm going to compare the 20th frame of this sequence and the 25th frame. So that is what I'm going to do. So if you want to see the sequence, you can use implay. So implay capital A will allow you to see what is the sequence, how is the video. That video can be seen by implay. Right, so until that initializes, we can go ahead. So this is 20. So I have taken the 20th frame, of this A and the 25th frame. So I'm going to compare the 20th frame and the 25th frame for now, and the same things will start. So just the same thing that I had explained before, and yeah, so has that. Oh yeah, so this is the sequence that we have. You can play it from here. So this is the sequence that I have, and for now what I'm going to do is I'm going to only see the 20th frame, which is right. So this is the first image that is going to get compared to, this is the first frame that is going to get compared to this frame. So let us see what we get. So even after resizing, it is taking a little time. Right. So here you can see the image. This is the 20th image. Let me put it over here. And this is the QR plot. So one thing you can notice that this is upside down. So that is because the QR plot gives 0, 0 over here. So in if you want to rotate these, you can go to the tools and there's an option rotate 3D. I don't know why there is 3D for this kind of thing. So this is, oh, so it is a bit tedious to rotate this plot. Oops, I don't know what I'm doing. No, this is not the right direction. Oh my god. So basically you can rotate it as you want. I don't know what is happening. This is, yes, I guess this is the right. Oh, okay. stay still, right? So this is the right kind of a plot that I wanted. So you can see that these vectors over here, they belong to this car, and these vectors over here, they belong to this car, and these vectors over here belong to this car. So you can see the motion that is calculated for this and this car over here. So if suppose you don't want to do this rotation business, the other thing that you can do is, if you don't use a figure plot over here, you can use a hold on. So what a hold on does is, it will uh, plot this keyword over the IM show that you have done. So let me run it again to show you. There was this breakpoint over here. Yeah, also there is this TIC and TOC. So this tells you how much time did it take to run the code. So this is also something that so you can see it took 24 seconds to run this code. So that is also something that you can use. So TIC is something, I guess, time in count and time out count, something like that. Right. So if you see, this is a better image. So here you can see these blue vectors are corresponding to this car, and this car is going like this. These some of the blue vectors are corresponding to this car, which is going like this, and this blue vector for this car, which is going like this. So one more thing that you can do is you can apply the optical flow algorithm on the entire image, on the entire video. So let me show you that also. So now what I've done is I've made a loop. I hope this is right. Yes, let me remove this also, and let me remove this also. Right, so if you see over here, I have made a loop. So this loop this loop is for the time. This is the frame intervals. So what I'm going to do is I'm taking the first frame. Also I will need this. Yes. So first I'm going to show the first frame, and that on the first frame I'm going to plot all the vectors for the other frames. So here I'm running it through the frames. So size of a comma 3 will give me the number of frames that I have. So it will give me 41, and minus 5 because I'm going to compare the first frame with the fifth frame. Then the fifth frame with the 10th frame. So this again I am doing it for speed. You can compare each frame, first with the second, second with the third, and the story. But I did not find it that helpful, and it is unnecessarily increasing the time. So I have decided to just skip the middle frames. I'm just taking the first, fifth, 10th, 15th like this, and let us see what happens. So this will also take some time. I guess it takes some 50 seconds to run. So here you can see the image, the first image, that is the first frame is plotted over here. This will come after this runs. So I hope this particular thing is clear. If you have any comments, yes, it has run. So this is the first iteration, I guess, for the comparison between the first and the fifth frame. So that has come over here. Now it is comparing the fifth and the 10th frame, so that has come over here. So you can see slowly these blue lines are coming in the right, because this car is going to come like this car is going to come like this, and this car is going to go like this. So you will see the vectors like this. It would be good if I could zoom this, but since the algorithm is working, it will not let me do that. Yes, so see, you can see slowly the blue lines are coming over here. So it is basically a very basic sort of tracking, very basic sort of tracking. So I just found this interesting, so I'm showing it to you. So you can see this car is coming over here. Actually, this did not used to take this much time. I don't know what. There's something going on in my PC, I guess, which is making it slow. Yeah, I get that. I guess that is. So here you can see this particular car has moved till here. That is what we can say. This car has moved till here. This car has moved till here, and that is a sort of very basic kind of a tracking. So that's all for this video. I hope you have understood the Horn and Schunck algorithm and you can now code it in Matlab. So that's all for this video. Thank you so much for watching. Thank you.